Red sky at night, shepherd's delight. Red sky in the morning, shepherd's warning. In the past, people once used old sayings like that to predict the weather. These days, scientists employ modern technology and complicated mathematical models to make forecasts many days in advance. In the start of a new series of in-depth feature reports on the science of weather prediction in Taiwan, today we find out how the experts use different techniques and tools to get a complete picture of complex weather systems.
Before the 16th century, people used the naked eye and relied on their experience to predict weather changes. After the 19th century, with the advancement of weather science and modern technology, forecasting rapidly developed. Now we can use technology to make long-range predictions for weather forecasts and other services.
We can
currently predict weather changes 10 days in advance. So for example, when the typhoon system is starting to develop at sea, when it is still thousands of kilometers away, in our numerical forecasting models, we can already see some estimates. Even though the typhoon is still 3 to 4 days away, we can have a fairly good grasp of the situation.
The system works by inputting atmospheric data into a three-dimensional grid, which is analyzed by supercomputers to calculate possible weather changes. This is what's called numerical weather prediction. For Taiwan, atmospheric systems closer to the island have a greater impact on the local weather, so the Central Weather Bureau tends to analyze a relatively small grid. But in different situations, other techniques are used. When extreme weather conditions are approaching Taiwan, satellite or radar comes into play.
When the typhoon is at sea, monitoring is done mainly by satellite. The satellite mainly sees the upper level of cloud in the weather system. It can observe the finer details inside the weather system. This is when numerical models can be a tool to fill in some of the gaps, to understand how the system is going to change in the future. When it gets closer, we use radar or ground weather stations to more precisely describe it.
In Taiwan, extreme weather tends to manifest itself in torrential rain and floods. Reflected radio waves from radar antenna can be used to predict rainfall. The strength or weakness of the echo from an emitted pulse as it bounces off water suspended in the atmosphere can be used to calculate the distance of the object.
To more clearly understand the structure of typhoons and their future movement apart from numerical weather prediction, we can use radar data, because from that we can see the internal structure of the typhoon or rain system and get a better grasp of the position and strength of the eye of the storm.
The experts use a variety of forecasting techniques to analyze the formation, proximity, and impact of the latest climate trends and weather systems around Taiwan. In recent years, there have been more breakthroughs in the science of monitoring typhoons with the introduction of storm chasers and unmanned aircraft. Yet, in the unexplored territory of climate change, we're likely to face greater challenges in the future.
According to chaos theory, a butterfly flapping its wings in one part of the world can change the path of a typhoon on the other side of the planet. This example illustrates the complex nature of weather forecasts, but since recent blunders about how much rain typhoons called Meiji and Morakot would drop, there have been regular calls for inquiries every time there's a big gap between predictions and reality. It goes to show that the work of meteorologists is still largely misunderstood. In today's special feature on weather forecasting in Taiwan, we find out why it is so hard to predict rainfall.
Last year, the rain Typhoon Morakot dumped on southern Taiwan smashed the record books. Questions were raised about why the Central Weather Bureau didn't see it coming. There was almost a bigger storm of controversy about the gap between what the meteorologists could predict and the accuracy the public expected. But in the complex field of weather forecasting, the public has to accept that there will always be a margin of error.
The Central Weather Bureau uses a numeric model to predict the future path of a typhoon. The numeric model has an inherent margin for supposition. Also, there will be a margin of error in observable data. Because 70% of the globe is ocean, ocean data is limited. So with the ocean data error and numerical model error, in addition to Taiwan's relatively complex topography, these things increase the difficulty of forecasting. It's hard to avoid forecasting errors.
Despite keeping up to date with the latest reports, surveys, analysis and research, and using satellite and radar to track weather systems, the best meteorologists can do is produce a percentage forecast rather than a cast-iron prediction. In July 2008, when Typhoon Fenghuang formed over the Pacific, Taiwan, Japan and the United States predicted the storm would hit land at Taidong, Hualien and Yilan respectively. The 3 points stretch along virtually the entire east coast of Taiwan. This example shows the challenges facing meteorologists.
Taiwan is on the furthest westerly side of the Pacific, which is a very large area of ocean, with very limited weather data. After satellite, we got quite good readings of weather systems, cloud systems, and cloud observations. But there is no way to find out about the internal fine details of those systems. When we use numerical weather forecasting technology to predict the weather, we need to know pressure, temperature, humidity, and wind data. A satellite can provide all of those, which is a big challenge for the forecasting technology of numerical weather prediction.
The Central Weather Bureau's 24-hour predictions for the expected path of typhoons has improved from an average error of 219 kilometers to 110 kilometers, making it among the best in the world. But in the complex area of rainfall, the Bureau is unable to provide accurate forecasts. Rainfall predictions are influenced by geography, wind speed, storm path and other fine details that make predictions a very risky business. Typhoon Morakot is a classic example. Although meteorologists cannot accurately predict rainfall, the experts still try to provide maximum and minimum predictions. Meanwhile, the public needs to keep up with the latest forecasts and weather reports and always be prepared for the unexpected. They say it's wise to expect the unexpected. Last year, Typhoon Morakot reminded us that unpredictable weather conditions can cause unprecedented disasters. Apart from the loss of lives, property and infrastructure, the economic cost of the storm was astronomical. The Disaster Recovery Committee estimates that the total loss to forestry, fishing and farming was $880 million. In the latest in our series of reports on the weather forecasting in Taiwan, we learn more about the correct way to understand typhoon warnings.
At the UN meeting on climate change in Copenhagen, it was announced that there were 245 natural disasters around the world from January to November 2009. 224 of those were caused by the weather, and the most dangerous region was Asia. In Taiwan, the cost of weather-related disasters is over $630 million a year, with typhoons and plum rains causing over 90% of that total.
In
the last 10 years, typhoon rainfall has clearly increased. In terms of flooding, Typhoon Nari was a very good example. Then there were the Great 88 floods in southern Taiwan, and even landslides are getting more serious. So in general, weather disasters are increasingly affecting us.
Despite the increasing threat, past experience shows us that weather forecasts are either too dramatic or too conservative. Overstated warnings can cut losses, but also waste resources, while understated warnings create the risk that people will be unprepared.
The Central Weather Bureau is the first source of information for disaster prevention. As soon as the Bureau announces the most likely path of a typhoon, the information is immediately sent to the Disaster Response Center. After it gets the weather report, it will put together the areas that are at risk of suffering rock slides or broken bridges, and combine that with the weather report. And in places that may be hit by disaster, organize evacuations or prepare to seal the bridges.
To raise awareness of the danger of landslides and flooding, the Weather Bureau has organized rainfall into 4 categories, from heavy to extreme torrential. but more needs to be done to get people out of the habit of only consulting the most likely path of a typhoon and ignoring the other possible routes.
I hope everyone can use our 70% potential forecast and not use the single path map, which may make people drop their guard. People can take the typhoon's current position and its prediction position in 24 hours and draw a straight line between the two, and people outside the affected areas may become complacent.
After being rocked by the 9/21 earthquake and then pounded by the 8/8 storm, Taiwan is no fit state to be hit by another disaster. Given the nature of the situation, the authorities have a responsibility to monitor the level of a disaster preparedness in potentially dangerous areas and respond appropriately to the latest weather reports. With better preparation and heightened awareness, damage can be reduced to a minimum.